Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at empirical and molecular formula. An empirical formula of a compound is the lowest whole number ratios of atoms in that compound. Here's again, the lowest whole number ratios, where the molecular formula of a compound talking about the actual number of atoms of each element in a compound. For example, sucrose has a chemical formula. Now this is the molecular formula of 6 carbon, 12 hydrogen, and 6 oxygen. But notice how 6, 12, 6, the common multiple we can divide it by is 6. So that can be simplified into CH2O, and this is your empirical formula. So keep that in mind. Molecular formula tells us the actual number of atoms. Empirical tells us the lowest whole number ratio. Now, the biggest challenge for this type of problem is how do we determine the empirical formula from the experimental data that we know about each element in a compound. So here are the steps. The first step is that we need to determine the mass. Sometimes the mass is in grams, it's given to you, so just use it directly. But a lot of times they're trying to trick you. They give to you in percent composition. So when that happens, all you need to do is change percent and replace it with gram, because we're assuming it is out of 100 grams. So it doesn't matter what sample they gave to you, as long as they give you in percent composition, we have to assume it's out of 100 grams. So that way we can convert percent to mass easily. Now we are going to convert the mass to mole using the molar mass and using information from the periodic table. Once you're done, you divide by the smallest number of moles to give you that ratio again. That's what the ratio is coming from. When you compare ratio, you're either comparing to the, when you are making a whole number ratio, the only way you can do that is by comparing to the lowest number of mole. And in most cases, or in some cases, when you divide by the smallest whole number, it doesn't give you the whole number. It gives you like decimal number. Remember 0.5, that's equivalent to 1/2, and 0.33, that's equivalent to 1/3, and then 0.25, that's equivalent to 1/4. So to get rid of that fraction, we have to multiply by 2 for 1/2, 3 for 1/3, or 4 for 1/4, because again, 1/4 is 0.25, 1/3 is 0.333, and 1/2 is 0.5. And then that will give us the whole number. Once you do that, make sure you multiply to all answer, okay? Not just one, but multiply to all the answer. So I'm going to show you a problem that we deal with that. But now let's go do the easiest one first. So here we have a sample of what? A 15-gram sample of an unknown compound has percent composition of 54.5% carbon, 9.2% hydrogen, and 36.3% oxygen. Do we care about this? No, this is irrelevant to us because now we have percent. That's the most important thing. So we can assume that this is out of grams, okay? And sometimes they can trick you by just giving you 2 of them, and then you have to subtract, okay? That's basic math from there. And we're going to cover that problem later on. So in this case, easy because it gave us each percent for each of the element. But again, just to point out, if you are only given 2 of them and there's 1 left, of course you're going to take 100 minus whatever is given to us, okay? So in this case, easy already because we are given each percent for each element. Now let's go back and do this. So in this case, first step, right? Convert them to mole. So we have 54 gram. So for carbon, we have 54.5 grams of carbon time. The molar mass for carbon is 12.01 grams of carbon, and on top is 1 mole of carbon. Now let's continue. We have what? We have hydrogen. We have 9.2 grams of hydrogen time. Again, 1.008 grams of hydrogen, and we have 1 mole of hydrogen. Now for oxygen, what do we have? We have 36.3 grams of oxygen time 16.00 grams of oxygen, and now we have 1 mole of oxygen. So let's do the basic math, right? You can do this in your head already in terms of setting up, and then The next step is use a calculator to divide and to get a number of mole. So here we have 4.54 moles of carbon. Okay, notice how I show you all the work, but when you are solving this on your actual test, especially multiple choice, you don't have to write all this out. So now what do we have? We have 9.12 moles of hydrogen, but if it's a free response, you have to show all your work out, or else you won't get credit for it. So we have 2.27 moles of oxygen. There you go. Which one is the lowest one? 2.2. So I'm going to change this to a different color. Okay, so I'm going to change this to blue. So now we're going to divide everything by 2.027. 2.027. Again, we are trying to set up a ratio relative to the smallest one, okay, to give us a whole number. And now we plug this in the calculator. This turned out to be 2 exactly, and this turned out to be 4.01, but we can estimate that to be 4, and this turned out to be 1. Of course, it's divided by itself. So now what do we have? That tells you have 2 carbon, 4 hydrogen, and 1 oxygen. So our chemical formula is C2H4NO, because we don't really write the 1. That's how we do it. Now, are you ready to try to do the advanced question one? Now, let's try to solve one sample problem that deals with decimal and how we have to multiply it to get rid of that decimal to get a whole number. Here we have an unknown sample consists of 21.9 grams of carbon, 1.41 grams of hydrogen, and 6.7 grams of oxygen. Determine the empirical formula. So going back here, we have carbon, 21.9 grams, okay, of carbon time its conversion factor for the molar mass. So we have 12.01 grams of carbon, 1 mole of carbon. And then we have hydrogen. Here we have 1.41 grams of hydrogen times the conversion factor right there. So 1.08 gram of hydrogen, 1 mole of hydrogen. This is all coming from the periodic table. And then for oxygen, we have 6.7 grams of oxygen. Oxygen is 16.00 grams of oxygen, 1 mole of oxygen. So again, this is talking about oxygen atom, not oxygen gas, okay? So we keep in mind. Now, let's do our basic math. Plug in our calculator. 21.9 divided by 12.01, we get 1.82. And then for this one, 1.41 divided by 1.08, we get what? 1.39. And for this one, we have 0.42. So what is our lowest number? This one's our lowest number. So we have to divide everything by that smallest number of moles. Of course, this equal to 1. And this right here, 0.42, turned out to be 3.30. Notice how right there, right? And this 0.3 right there is relative to or equivalent, almost estimation by 0.33 and then this one here we have 0.42. And then what do we have? In this case, we have 4.33. And again, even though we have this 0.3, but you can see that this right here, right? We kind of have to play a game of estimation right there, using our best educated guess. So again, 0.3, we have to multiply everything by 3, because 0.33 is equivalent to 1/3, okay? So you multiply by 3, multiply by 3, multiply by 3. This one is 3, and 3.30 times 3, that turned out to be 0.99, but we can round it up to 10. And here we have, what's this? This turned out to be 12.99, and we can round this up to 13. So this is our final number. So we have C13, H10, and O3. And that is our empirical formula. So again, we have to use our best educated guess when it comes to number, okay? And then let's go check our answer. When we enter our answer, again, we don't space or we don't use subscript or superscript, and it's case sensitive. So we have, what is this? C13, H10, and O3. And there you go. And as always, if you have any questions, take a picture of your work, put it in the forum, and then we can help you from there. And we'll see you next time on another video.